This lesson is for Unit 3, Lesson 6, and multiplying polynomials by monomials. So multiplying polynomials by monomials, you're basically using the distributive property to multiply that outside term through the parentheses. And if you remember, when we multiply where the base is the same, you add the exponents. So for this first one, 4x times x, each of these think of having an exponent of 1. So 4x times x, when you multiply that term, you end up with 4x squared because you add those exponents, 1 plus 1 to get 2, and then plus 4x times 3. 4 times 3 is 12, and then we still have the x there. And we can't combine like terms because there are no like terms. This one has a squared exponent, this one does not, so this would be our answer. On the second example, multiplying through the 6x, so 6x times x squared, adding those exponents, you end up with 6x, and then 1 plus 2 is 3, so 6x cubed, and then 6x times a minus 8. You can think of this as being 6x times a negative 8. Then you know your answer is going to be negative or minus a 48x. And again, these ones cannot be simplified because they're not like terms. A couple more examples. 8x times 6x, multiplying the coefficients. So 8 times 6 is 48. And then multiplying the exponents. When you multiplying the variables, you add the exponents if they're the same base. So x to the first times x to the first becomes x squared. And then plus 8x times 2, you get 16x. Now this last one is written a little bit differently. You can leave it the way it is or rewrite it, but you're still multiplying through that 8x squared times both terms. So 8x squared times the first term, 8 times 3 is 24. X to the first times x squared, you end up with x cubed. And then 8 times 7 is 56, and then x squared. You can also apply this multiplying monomials through where there's 3 terms called a trinomial. You're still using the same process. So multiplying the 7y times your first term, multiply that 7y times your second term, and then multiply that 7y times your last term. But watch for the subtraction. It helps to think of this as being a negative 4y and a negative y. So 7 times 3 is 21. Y, think of y to the first times y cubed becomes y to the fourth by adding those exponents. 7 times a minus 4 is a minus 28. Y to the first times y squared is y cubed. And then 7y times a minus y, think of this as a minus 1y. So 7 times a minus 1 is a minus 7. Y to the first times y to the first, you end up with y squared. And then one more example. Same exact process. Make sure you multiply that outside term through the parentheses. So a squared b times your first term, a squared b times your second term, a squared b times your third term, and then a squared b times your last term. So since there's no coefficient here, all of these numbers are going to stay the same because it's like multiplying by 1. So a squared b times 21ab cubed would be 21. And then looking at our a variables, a squared times a to the first, you end up with a cubed. B times b cubed would be b to the fourth because there's like a 1 here. Next term, 1 times 5 is 5. A squared times a to the first, you get a cubed. B to the first power times b squared, you end up with b cubed. And then minus 3, a squared times a is a cubed. B times b is b squared. And our last term, a minus 7. And since there's nothing you're multiplying these by, there's no variables over here, it would just be minus 7a squared b. And then just double checking your exponents, none of these terms match exactly. Even though this is an a cubed and this is an a cubed, we can't add them together because this is 21a cubed b to the fourth. This one is 5a cubed b cubed. So they're different terms, so we can't combine them together. So this would be our complete answer.